Hello, this is lesson number 9, and we are continuing on to learn about greatest common factors, and we're going to do some word problems and apply what you're learning. So the warm-up, you should pause the video and try the warm-up, and then of course I'll show you the solutions worked out. You're going to use the factor ladder method, and you're going to use the list method. So let me just go ahead and show you on the list method. If you're not good with listing factor pairs, you could get a multiplication chart. And basically what you're doing is you're trying to find, so I'm going to just do 60 because it's the bigger product. So when I'm looking for 60 in the chart, I really can just go through, well, I know there's 1 times 60. 60 would be way down here. It's not going to be on my list. And then I go through the 2's. Oh, look, and I see a 60 there. I could go through the 3's, and I just go through each of the columns looking for the product of 60, which is in my multiplication chart, right? And so everywhere I see a 60, I know that's one of the factor pairs that I need to write down. But then you're also going to remember that the multiplication chart goes in 2 directions, right? So the idea is that 30 times 2 is the same as 2 times 30. So at some point we start getting duplicates, right? But the important part is that you know how to find the 2 factors that go with it. So when I see the 60, I know that the factor pair is 30 times 2. And when I see the 60 here, I know the factor pairs are 3 times 20. So this is how you use a multiplication chart to find factor pairs when you're making lists of factors. And then the 4 is 4 times 15, and the 60 is 12 times 5, and then the last one is 6 times 10. So now you can really see all the factors, 2, 3, 4, 5, 6, 10, 12, 15. So you can see them all written here. The only one that you can't see is the 1 times 60 because it's too long, right? It's not on my list. So that's just a quick tip on how to use a multiplication chart to find the factors when you're making a list of factors. Okay, so let's clear that. I'm going to move this over, and you need to go ahead and list the factors. I'm going to write my t-charts back. There's 60, there's 15, 1 times 15, and 3 times 5, 1 times 60, 2 times 30, 3 times 20, 4 times 15, 5 times 12, 6 times 10. I go through my list and I circle all the common factors. Those are common. That means they're in both lists. But then I have to choose the greatest common factor, which is the biggest number that I have circled, which of course is 15. So the greatest common factor is 15. Now I'm going to do the factor ladder method, but before I do, remember I always write down the 3, 5, 7, 11, 13. I write down all my prime numbers. And then I start dividing by one of these prime numbers. It's easiest, if they're even, to just go ahead and start dividing by 2. 60 divided by 2 is 30. 84 divided by 2 is 42. Divide by 2 again. Oops. Wrong thing to put out there. I'm dividing by 2. And the 15 goes inside. And then 42 divided by 2 is 21. And now they're not even, they're not divisible by 2, so I go to the next number in my list, which is 3. They are divisible by 3. I get 5 and 7. Once I get to this point, the 5 and the 7 don't have any more common factors. I stop dividing and I multiply the product of the primes together. That is my greatest common factor. There's my prime factors, and then I multiply all those together to get my greatest common factor. All right. So this is something that I don't want you to write, but I want you to think about it. So the idea is when you're looking at multiple choice questions, sometimes there's some answers that you just eliminate right away because they don't make sense. So I'm going to ask you I'm going to put a little caret in there, what 2 choices can be eliminated and why? So the idea is you're trying to see which of those pairs of numbers would have a greatest common factor of 15. So pause it, think about it for a minute, and then go back to the video. Okay, so when I look at A, I'm noticing that the two numbers are 10 and 15. So if I think about my factor list, right, this would be 1 times 10, and this would be 2 times 5. Wait a minute, 15 isn't even on my list. That's so weird. Oh, wait. Okay, that totally makes sense because 15 is bigger than 10. You can't have a factor that is bigger than the number, right? That's like saying, is 10 divisible by 15? Well, yes it is, but it's not a whole number, not whole number divisible, right? You can divide 10 by 15, but it's not a whole number. So this one I'm totally eliminating because when I'm looking at a greatest common factor, it can't be bigger than the number itself. Okay, so I'm going to look at 30 and 60. I know that these are both divisible by 15. I just don't know if the GCF is 15. So I'm going to skip it and say that one makes sense for a possibility. Now when I go to C and I look at 21 and 45, 45 is definitely divisible by 15, but 21 is not. So again, well, I mean 21 is bigger than 15, so I didn't have the same problem that I did with A. But I do know that 21 is not evenly divisible by 15, so I cross it off, right? So now I would have a little bit of work to do to make my list, but you can see how there's some answers that just don't make sense, so I was able to eliminate those two choices. All right, next. Okay, so this is an OYO. I want you to, on your own, try to come up with a pair of numbers whose greatest common factor is 10. So I'm going to set it up. I don't know if this will help you, but I like to always draw a picture. I start trying to picture something, and I'm picturing 10 and a 10 in a list of greatest common factors. And so this number and this number are the ones that I need to come up with. And then I started thinking maybe I could just start with 10 because 10 is a factor of 10. And so if I put a 1 here, then I've got 1 times 10 and 2 times 5. Okay, now all I need to do is come up with another number. Oh, if it's a multiple of 10, then it probably, oh, of course it has 10 as a factor if it's a multiple of 10. Okay, so what if I do something like this? What if I put in 50? So then I would have 5 times 10. And I could fill in the other numbers, right? 1 times 50. These aren't going to be in order necessarily. 2 times 25. Oh, I think that's it. Okay, so 1 is a common factor. 2 is a common factor, but the greatest common factor is 10. Well, wait a minute. What if I tried 40 or 30 or 20? It kind of seems like those would be common factors as well. So if I pick a number and then I multiply it by another whole number, I'm coming up with a pattern for how I can find the greatest common factor of two numbers. As long if I pick a number like 10 to be my greatest common factor, if I start with 10, then all I have to do is multiply it by 10 and I'll come up with another number that it pairs with that has the greatest common factor of 10. That's awesome. Okay, next. So here's our real life application. So the idea is you are filling piñatas for your sister's birthday. The list shows the gifts you're putting into the piñatas. You want identical groups of gifts in each piñata with no gifts left over. What is the greatest number of piñatas you can make? So you're going to learn that when you see questions that say you want identical groups, that's kind of telling you that you want to divide something out, right? And then notice they're asking me to find the greatest number of piñatas, right? So you're learning about greatest common factor. And it turns out that that's what we want to do. We want to look for the greatest common factor. And then I look over here and I'm going to circle, I've got an 18, I've got a 24, I've got a 42. The three different types of gifts, I'm trying to divide them evenly so that there's the same number of gifts in each of the piñatas. I don't know how many piñatas I need to buy. So I'm going to do this process of finding the greatest common factor, and that's going to help me find out, to figure out how many piñatas I want to buy. Now what I'm going to do is I'm going to move my screen down a little bit. I am going to insert a page because I need to show you what to put in your notes because you're not going to write all of this. So now I'm going to put a page. Okay, so here's what we're going to do. We're going to abbreviate, and I want you to write this down. We are making piñatas with equal gifts oops, I wanted to say something a little bit different. With equal groups of 3 gifts. So there's 3 different gifts. So sometimes I just abbreviate a problem and it helps me make sense of it. Now I'm going to just abbreviate the N for nail polish. The nail polish was 18 and the E stands for earrings. I'm writing 24 and the lollipops is L and that was 42. And so the idea is I'm going to make a factor ladder. Oh my gosh, it's so long. This time we are factoring 3 numbers at the same time. The same process that you do with 2, it just looks a little bit different. So I'm going to put my nail polish and my earrings and my lollipops above those numbers. And then I'm going to write down my 2, 3, 5, 7, 11, 13. Those are my prime numbers. So same thing I did with 2 numbers at a time. Now I have 3. So I have to be careful and make sure whatever I divide by, that it's divisible into all 3 numbers. And guess what? They're even. Divide by 2. I get 9, 12, and 21. Now they're not even, but I recognize that they are multiples of 3. So I'm going to continue my list and I divide by 3 and I get 3, 4, and 7. Now here's the deal. The greatest common factor is the 2 numbers on the left-hand side. So it turns out that this is the number of piñatas that I need to make. Okay, oops, sorry, that's supposed to be above the N. So this is the number of piñatas, but it's also the greatest common factor. That's cool. And then you might be wondering what the numbers on the bottom mean. And it's really cool in this case because these numbers on the bottom, they tell me how many of each gift, how many of each gift goes in each piñata. So when I'm making those 6 piñatas, I would put in, right, I'm going to do this, I would put in 3 nail polish in each one, I would put in 4 earrings in each one, and 7 lollipops. And it's really cool when I think about the 6 piñatas times 7 equals 42. The 6 piñatas times 4 equals 24, and the 6 times 3 equals 18. That's so cool how that worked out. Okay, now I'm going to go to an Oyo. This one only has 2 numbers, and I'm going to ask you to find the greatest common factor, but this time you're dealing with 126 pieces of chocolate candy, 60 pieces of hard candy, and you're putting them into equal gift bags with no candy left over. So I'm asking you to figure out how many gift bags you can make. And so I also like to abbreviate on this one. I would do CC equals chocolate candy, and I would do HC equals hard candy, and those are my numbers. And so when I put 126 and 60 into my factor ladder, I abbreviate the CC and the HC. So this is the point where you've got this written in your notes, and you should pause it, make your list of prime factors, and then do your factor ladder and see if you can figure out how many gift bags, the maximum number of gift bags you can make. Here I go. 63, 30, divided by 3, 21, and 10. No longer divisible. Greatest common factor is 6. So it's 6 bags. Okay, I hope that was pretty easy for you. Next, so this is some critical thinking, where you think about whether the statement is always, sometimes, or never true. Oops, I need to move this down so that you can see this is in your textbook. So it's on page 35. It's number 28 to 30. So I want you to think about whether the greatest common factor of two even numbers is 2. And so sometimes what I do is I come up with an example. Well, first of all, if it's always true, every single example that you come up with will make it true, right? And for never, as soon as you find one example that is false, that's not always going to be the never. That's going to make it probable. No, it's possible that it's going to be in the sometimes. So what I do is I just kind of start doing a little bit of guess and check with what I know. 2 even numbers. Okay, so I'm going to start out with a couple of even numbers and see if the greatest common factor is 2. And so I could pick something easy like 8 and 10. So if I divide 2 out of 8 and 10, I get 4 and 5. So I'm done with my division, and I got 2 as my greatest common factor. Well, now I'm thinking, I'm kind of remembering the multiples of 10 problem, and I'm wondering what happens instead of starting with a small number. Well, what if I start with 4 and I double it? So I use 8. So now I divide 2, right? 4 and 8 are both even. I divide, I get, So now I'm seeing that the greatest common factor is 4. So I have one that has an even number of 2 and one that has, 2 even numbers, the greatest common factor is 2. 2 even numbers, the greatest common factor is 4. So this is sometimes true. Sometimes. Okay, now I'm going to go ahead and erase this and move my box down. Next, how about the greatest common factor of 2 prime numbers is 1? Okay, you know what I do? I start making a list of my prime numbers. So here's 2 and 3. Okay, so I've got 2 and 3. Here's my factor list. What's the greatest common factor? 1. Ooh, what if I test 5 and 7? Make factor lists for those. You see the pattern that's happening? Every time I pick 2 prime numbers, the greatest common factor is always 1. So this one isn't always. All right, let's look at the last always, sometimes, never question. And it says when one number is a multiple of another, the GCF of the numbers is the greater of the numbers. Wait a minute, I'm remembering the one. I'm remembering that when I had 10 and 20, the greatest common factor was 10. Oh, wait a minute. It's the greater of the numbers. I think it's not the greater of the numbers. I think it's always going to be the smaller of the numbers. Okay, what if my number is 5? And then a multiple of 5 is 20. So they both have 5 as a factor. Oh, yeah. Okay, so this one is definitely going to be never, because the GCF is always the smallest number. Okay, I hope you got a little bit of that. All right, this was only if I have time, so the homework is a formative. That was lesson 1.5. I'm calling it B because that was the second day that we spent on GCF. Okay, good luck with your homework.